state they are? Okay, what is their state of oxidation state of group 13 element? Which element? Group 13. This we are doing. So how much oxidation state are there? Its configuration you see. This is the NS2 and NP1. NS2, NP1. So two type of configuration is there. So what the configuration? First one is two there. Group oxidation number. Can you tell me group oxidation number? Group oxidation number is +3. And second one is there. Lower oxidation is there. Other oxidation number. So other oxidation number, what it can be? Other oxidation number. Other oxidation number is +1. So these two oxidation number they are exhibiting. +3, +1. Now, moving down the group, which effect is there? Inert pair effect. Inert pair effect. Inert pair effect. In inert pair effect, what they said, this electron do not participate. This electron do not participate in oxidation state. So what is there? Down the group, stability of +1 oxidation state increases. +1 oxidation state increases. The reason already you wrote. What the reason is there? Because of the inert pair effect. Second, you see.
Yes, sir.
Second one. What will happen to +3 oxidation stability of +3 oxidation state? Obviously, if +1 is increasing, 1 is increasing, so a +3 will be what? Its stability decreases. Okay. It is decreases. Now, let us go and back and read out the slides. What the slide is saying. See? Due to a small size of boron, the sum of its first three ionization enthalpy is very high. This prevents it to form +3 ion. It does not form the +3 ion. And force it to form only covalent compound. But as we move from the boron to aluminum, the sum of first three ionization enthalpy of aluminum considerably decreases and is therefore able to form +3 oxidation state. So boron +3 it is not forming because the IE1 plus IE2, okay, plus I3 ionization energy, third one. First, you remove the first electron, then second electron, third electron required more energy. So boron generally do not form +3, relatively less form, but aluminum form because first, second, third ionization energy, some of these energy are less. In fact, aluminum is highly electropositive metal. However, down the group, what is happening? Down the group, you read. Important point. Down the group, due to poor shielding effect of the intervening D and F orbital. Which one orbital they are saying? D and F orbital. Intervening means shielding effect. The increase in effective nuclear charge hold NS electron tightly. Which electron? NS electron. Getting? Responsible for the inert pair effect. And thereby restricting their participation in the bonding. And what they are doing? They are restricting their participation in the chemical bond formation or the oxidation. As a result, the only p orbital electron may involve in the bonding. In fact, in gallium, indium, thallium, both +1 and +3 oxidation are observed. The relative ability of the plus oxidation state progressively increase. So here you see the stability. Relative stability, what the point they are saying? Stability +1 oxidation state progressively increase. For heavier elements, they are saying aluminum, gallium, indium, thallium. This is increasing. In thallium, +1 oxidation state is +1 is predominant. So boron, aluminum, gallium, indium, and thallium is there. So this is the +1 is highest. Predominant. So +1 it is the increases, stability increases because NS2 electron is not participating in what? Oxidation state. Already they said no, this electron is not participating. And configuration you are having NS2 NP1. So if this is not participating, the only +1 oxidation state will be predominant. So this is there. Are you able to understand this point?
Yes, sir.
Okay. So oxidation state they did not mention here. Here you see the some more point you can see. Density it is increases down the group. Okay, like other element, other cases. Melting point it is decreases. Okay, because metallic bonding decreases. Boiling point it is also decreases. Okay. E naught value become the less negative. E naught value become the less negative. So now the next point here we are having this one. Whereas the +3 oxidation state is highly oxidizing in character. The compound in +1 oxidation state, as expected from the energy consideration, are more ionic than those of +3. You know, +3 higher oxidation state is what they are then covalent. Higher oxidation state covalent. Low oxidation state, I told you, low oxidation state. This is what? That is ionic. How? When I explain like that is this will hold the electron, pull the electron. So electron will come in the center. So it will be the according to Fajan rule, it will be covalent. So +3 oxidation state highly oxidizing and compound in +1 oxidation. It's expected from energy consideration more ionic than those of the +3. So +1 is more ionic. Here you see in trivalent state, the number of electron around the neutral atom in a molecule of the compound of these elements like the boron BF3 will be only 6, such as electron deficient. Okay, molecule like BH3 also, that is what we study, electron deficient hydride. So halides are also
Yes.
electron deficient. 6 electron are there. Molecules have tendency to accept the pair of electron to achieve the stable configuration. So what is happening? BCl is there. Here is the ammonia is having lone pair electron. It donated here. So it is forming this one tetrahedral and stable octet configuration. And thus behave as a Lewis acid. The tendency to behave as Lewis acid decreases with increase in the size down the group. Why? If you are moving down the group, tendency to accept the lone pair electron will decrease. So the acidic strength also decrease. Here you see BCl3 easily accept the lone pair electrons from the ammonia, BCl3 dot NH3. So here this is the compound is there. See, BCl3. Here is how many electron are there? 6 electron. Required 2 electron. Plus, if you see the NH3, what is there? NH3, one lone pair electron is there. It donated to it.
Yes.
It is donated. What bond is there? Coordinate bond. Coordinate bond it is formed. Coordinate. Can you see?
Yes. See, sir. I can see.
Huh. Now, another case, see, AlCl3 achieve stability by dimer formation. So, what it is?
Timer promise.
Dimer formation. So, AlCl3 is there, na? AlCl3. It dimerizes. So, it is forming Al
Sir, like two monomers combined to form one dimer.
one dimer. So, you see, this is the one molecule like that. And here is the another molecule. So,
Hmm.
molecule they
Sir,
form dimer. And this is the bridge atom. Bridge. This is the bridge atom.
sir, why this CL, sir? Why not the upper CL one?
Both here. Both are forming a bond. It is like that. Al, Al is there, na? Here is Al is there. In the center, what is there? Here, this one. This is called two electron, three center bond. Two electron, three center bond. Three atoms are there, and electron are how many are there? Two electron. Here is the similarly, this is also okay. Cl. Now, this is also example of banana bonding. Let us read and you will get to know here. In trivalent state, most of the compound being covalent are hydrolyzed in water. For example, trichlorides are hydrolyzing in water from the tetrahedral MOH. What is there? The point very important this one. In trivalent state, most of the compound being covalent hydrolyzed in water form the trichlorides on hydrolysis in water to form the tetrahedral. Okay, tetrahedral. Why they are forming the tetrahedral? They are accepting the electron pair. Okay, in the trivalent state. And if you are able to form the tetrahedral, you see, if they are able to, metal is there, na? If they are able to form the tetrahedral, means they are completing the octet. They all completed the octet, and there will be the one negative charge. because one extra atom acquired. So this one, the
extra electron.
extra electron will be there now. Its valency is 3, so
Yes.
it is gaining now.
Yes.
The hybridization state of element M is sp3. 4 bond is forming, that is sp3. Now see, aluminum chloride is acidified ferrous solution form the octahedral. What is that? AlH2O 6 times. This asked in the NEET exam. This one, NEET. Okay. So aluminum is having the d orbital. Okay. Third period element. So it can extend the octet ion. In this complex ion, 3d orbital of aluminum are involved in the hybridization state. So which one? D orbital is there, aluminum. I already explained you. Al,
Yes.
13. 1s2, 2s2, 2p3. 2p1 AR. 2p1, 2p,
S2 2S2 2P.
2p6, 3s2, 3p1, 3d0. So d orbital is there, now it can extend. That is why.
Yes, sir.
Now see, this value you read by yourself in text problem. We are lagging the time, so I'm not explaining. Later on, we will be good. Okay, here the reactivity towards water. See, not the all are reacting like that. If the +1 oxidation state are there, so it react differently, and other one react differently. So boron is unreactive in crystalline form. Boron
Yes,
is
sir.
unreactive because it's, you see now, it is the hardest one, hardest in the group, hardest in group. So that is, it is non-reactive. Next one, aluminum form a very thin oxide layer on the surface which protect the metal from their form further attract. So aluminum
So
also
that is
do
a
not, yeah. Al2O3 it form the oxide now, so it is also do not react. Aluminum form very thin oxide layer on the surface which protect metal from further attack. This is from the 10th standard. You study this one.
yes, sir.
Amorphous boron and aluminum metal on heating in air, B2O3 and Al2O3 respectively, with dinitrogen at high temperature, they form the nitrides. So see, if you are heating this one high temperature, then it form Al2O3, and if the nitrogen, it form the En. Why the formula of En is like that? Suppose Al you are having 3 and nitrogen valency 3. So cross multiply it will be what? Al3 and 3. 3, 3 cancel out. So formula will be Aln. Now, the nature of these oxide varies down the group. Boron trioxide is acidic. React with basic metallic oxide forming the metal borates. So boron trioxide acidic and react with basic metallic oxide forming borates. Aluminum gallium oxide are amphoteric. That one you study now. Al2O3 is amphoteric. The aluminum
Yes.
Ca2O3, these are amphoteric oxide. Those indium, thallium are basic in their property. So that you keep in mind, because down the group metallic character increases. So if you talk about gallium oxide, no, indium, and this one is indium is there, thallium is there. Okay. So these oxide are the, InTO3. Because metallic oxide are strong. So metallic, this becomes the metallic character, na? Down the group metallic character increases. So this becomes the basic. Reactive towards acid and alkalis. So they are the amphoteric. Aluminum dissolve in the dilute HCl, liberate hydrogen. So it is from AlCl3 is forming and liberating the hydrogen. However, concentrated nitric acid renders aluminum passive by forming protective layer. So aluminum, if you are treating with the HNO3. So protective layer, so after protective layer, no reaction. Further reaction, it is not forming. So that is, it is also the 10th topic. This is 10th. You know very well. With the aqueous alkali, this is what is forming the sodium tetrahydroxoaluminate and 3 hydrogen. That is why aluminum react with both metal, what? That is acid and base. So that is aluminum is what? That is called amphoteric. Amphoteric metal. Aluminum and zinc we study in the, they are amphoteric. Why? They are reacting with the metal and non-metal both, acid and base both. So that is why they are amphoteric. You study in the 10th, yes or no? Tanmay, hello.
Yes, sir. Sir, audible, audible.
Yeah, so aluminum reacting with NaOH in aqueous medium. This is forming tetrahydroxo aluminate. Okay, this one is compound. You just remember this compound. They can ask in the important this one. Okay, so this you need to remember. Reactivity towards halogen, it will give the EX3 types of halide. There is no important things. Trends of anomalous properties of the boron. I already told you boron is going to show the anomalous properties because of what the reason is there, because of the small size, lack of d orbital. They are going to show the anomalous properties. So that is, I'm not explaining this one much because already the general explained. Some important compounds of boron. I'm going very fast, okay, to finish that one. When you are trying to attempt the this one Akash test today,
Sir, probably in the night.
so is there physics class today?
Yes, sir. So physics class is after 10:30 in the night. So that is very much late.
Physics syllabus is over. Physics syllabus.
No, some parts I have to do by myself. These are most majority is over.
Okay, okay. Now see, the some important compound are there. That is the borax is there.
Yeah.
Borax.
So like,
Okay.
okay, professor physics portion was this one. So the gravitation, mechanical properties of solid, mechanical properties of fluid, and thermal properties of matter. So sir, except for the properties, sir, all are done.
Okay. All are done. Good, good, good. How sir is finishing the syllabus? I don't know. Very fast. Maybe you may not be the thoroughly you may not be studying. That is why getting finished or what?
Sir, actually, some parts I am studying, whatever I am studying from the school, that is, we are not repeating it anymore, sir. Only the topics which are not taught in the school, but here it is taught, so that much only sir is doing. So, sir, that is why it is completing fast. But, sir, in chemistry, we are very much ahead of the school, sir. These things are not even started also. So, sir, that is why we are having to study the full chapter. So, sir, that is why it is taking. Sir, if you remember those the first chapters like the basic concept and structure of atoms, so that took less time than this thing.
Yeah, yeah, correct, 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 correct.
Sir, because about those things I am having a background knowledge by the school teaching also. But sir, now in school they just completed the redox reaction. So sir, now I do not have any background knowledge on this chapter. So it is a completely new chapter for me.
Yeah, yeah, yeah. Correct. Not a problem, not a problem. Okay, let us see this one, borax. They will generally ask the formulas only. Now, this exam is not going to be that much tough. Basic question they will ask. If you have general idea, then also you can attempt most of the questions. See, it is the most important compound of boron. It is white crystalline solid of the formula Na2B4O7.10H2O. In fact, it contains the tetranuclear unit. Tetranuclear unit. B4O5OH 4 times. Okay, if you are summarizing this one, so this will give this one compound will give how much? 9 5 4 9. It contains the tetranuclear unit. In fact, it contains tetranuclear unit. You need to memorize this one. And correct formula therefore is Na2B4O5OH4.8H2O. So the same molecule is represented in different form. This form it is represented. Okay, if you count the same number, it is the valence one. It is the valence one. With this compound, this is the valence same one. Next one, you see borax dissolved in water to give the alkaline solution. Here it is there the orthoboric acid it is giving, and that is anywhere. So the solution is becoming, if you are dissolving borax in the water, it is giving the basic solution. Next point, see, on heating borax, first loses water molecule. This is what losing this water molecule. Water of crystallization loses. Then molecule swell up. This is the sodium metaborate is swell up. On further heating, it turn into transparent liquid, which solidified into the glass-like material known as borax. Borax base. So they can ask,
Na2 before also sodium metaborate.
sodium metaborate is there. NaBO2, not Na2B407, what you are saying. NaBO2 plus it is the boric anhydride, B2O3. This is altogether is known as what? Borax bed. Borax bed. It is used. Borax bed is very important one. Here you see what is the use here. The metaborate of many transition metal have characteristic color. Therefore, borax base test can be used to identify them in the laboratory. So borax base test is there for the various compound. When borax is heated in the Bunsen-Vernon flame, COO, you know, copper first oxide on a loop of platinum wire, blue colored bed is formed.
Sir, this is the cobalt oxide, sir.
Cobalt oxide. Cobalt second oxide. Second oxide. So this will give what the color they are saying? Blue. So this is the detection of the metal it is going to be used. Which one? Borax bed. Okay, this one.
Yes.
NaBO2. Now see the next one. Orthoboric acid. H3PO3. This is called orthoboric acid. You can represent this one. B H3BO3, BOH whole thrice. Sometimes it is looking like that it is base because OH is there, but it is not base. It is the H3BO3. So orthoboric acid H3BO3 is white crystalline solid with soapy touch. What is there? Touch is soapy. It is sparingly soluble in water, but highly soluble in water. In hot water, it can be prepared by acidifying an aqueous solution of the borax. Okay. If you are acidifying this one, okay, they are saying how you are preparing acidification of borax. So here is borax is there, 2HCl in water, it will give the orthoboric acid. It also formed by the hydrolysis reaction with the water and dilute acid of the most of the boron compound. So any of the boron compound you can take and you hydrolyze with the water. It will give the boric acid. Next one they are saying layered structure in which the planar BO3 units are joined by hydrogen bond as shown in figure. So here you see it is having the layered structure. How the H3BO3 you can see this one. So they are forming the layered structure if you can see.
Yes.
They are going to form the layered structure. Okay. And what is the ring is there? Hexagonal. Hexagonal ring. This ring is hexagonal ring. So boric acid is a weak monobasic acid. It is not a protonic acid but act as a Lewis acid by accepting the electron from the hydroxyl ion. So this is boric acid is there. It is accepting the electron OH group. It is accepting and releasing the H3O plus. So it is acting as a what? That is AC. Always keep in mind this point. This is very, very important point. They ask boric acid is a weak monobasic acid. It is not the protonic acid. It is not giving the proton, but act as a Lewis acid by accepting electron from the hydroxyl. So it is not a Lewis acid because it is accepting the what they are saying. It is the not protonic acid but Lewis acid. Lewis acid. It is Lewis acid. Lewis acid, not protonic acid, not protonic, but because
Sir, what is the difference between Lewis acid and protonic acid?
Lewis acid means they accept the lone pair electron. It is accepting OH minus. It is accepting. Here is BOH thrice is there. No? It is accepting this one from the water. So it is forming BOH 4 times and negative charge. So it accepted the this one negative charge, electron of negative charge. So acting as a Lewis acid. Lewis acid. But it is not giving H3BO3 if you are talking about BO3 does not give its own proton. It does not give. So not a, that is why they are saying, no, it is not a protonic acid. Getting it is not giving proton. H3BO3, it does not give its own proton. It gives the proton maybe from the water, but it is not giving its own. On heating orthoboric acid above 370 Kelvin, metaboric acid HBO2, which is further heating yield the boric oxide B2O3. So H3BO3, HB आशा कोई आया है देखो ना यार. So H3BO3 is there. Firstly, it is giving HBO2 and then finally it is giving B2O3. This is there. Here the here you see Tanur, why is boric acid considered as weak acid? Because it is not
So not
able
able
to
to use
release
the
H plus
expression of
ion on its own. It receives OH ion from the water molecule to complete its office and turn to release H plus. Turn to release H plus of what? Water molecule, na? See, BOH whole thrice is there. This is the HOH. So it is giving what? BOH 4 times, and that is minus. And then H plus is of what? This H plus is of water molecule, na? So this is not the no, protonic acid, but it is the Lewis acid. And it is not giving its own proton. So it is not the strong acid. Now you see here, next compound is diborane. This compound is what? Diborane, B2S6. Actually, BH3 is there. If you are multiplying, it will give B2S6. The simplest boron hydride known is the diborane. It is prepared by treating boron trifluoride with the lithium aluminum hydride in diethyl ether. See, BF3 is there, lithium aluminum hydride is there. This lithium aluminum hydride you study in the hydrogen chapter. So it is giving B2H6. Okay, diborane. A convenient laboratory method for the preparation of diborane involves the oxidation of the sodium borohydride with the iodine. Okay, here you see NaBH4 is there, sodium borohydride treated with the I2, it will giving another B2S6. And again, BF3 you can treat with the NaH, it can give the B2H6. So diborane is colorless, highly toxic gas with the boiling point 180 Kelvin, very less. Diborane catches fire spontaneously upon the exposure to air. It burns oxygen, release an enormous amount of energy. So B2S6 in oxygen, it is burning and giving the how much? 1976 Kelvin energy. This is there. If you are treating with the water, it will give the boric acid, orthoboric acid. If you are treating with the trimethylamine, it will give the coordinate compound. Okay, adduct, that is called adduct. Similarly, if you are treating with the carbon monoxide, it is also forming the adduct only. So here is C2H6 are there, treating with the ammonia. So also it is giving the firstly it is giving the complex, and which on decomposition is it giving the, this is called boragine. Okay, this is important, boragine, very important, very important. If you are treating with the diborane with the ammonia, it is giving the boragine, Zene. That is called inorganic benzene, inorganic benzene, inorganic benzene. Okay, how the structure is there? Boragine, you can see B is there, N is there, N is there. This is not N. Then again B, and finally it is N. N. So what is there? H3BO3, na? See, B3N3. This we explain. Now we are having the hydrogen. So every places it will go the hydrogen. H6 is there. And alternate single and double bond will be there. So this is what is called boragine. Boragine inorganic benzene. This is very important. They may ask today one. So reaction with ammonia diborane gives the initial B2S6.2NH3, which formulated at this compound intermediate. Further heating gives the boragine B3N3S6, known as inorganic benzene, in view of its ring structure with the alternate BH and NH group. Next one you see, Tanvir. The structure of diborane is shown in the figure. 4 terminal hydrogen atom and 2 boron atom lie in the one plane. Above and below this plane, there are the 2 bridge hydrogen are there. Bridge hydrogen. These and these are the bridge hydrogen atom. For the terminal BH bond is regular 2 center electron bonds, while the 2 center, see the term here. 2 center, 2 electron. 2 center, 2 electron. Which one? The 4 terminal. These whatever the terminal are there, 1, 2, 3, 4. 2 center, 2 electron bond. There is no problem. bond, while the two breeds BHB, what is there? BHB, what is their bond are differed. It can be described at 3 center, 3 atom, boron, hydrogen, boron, 3 center and 2 electron, 3 center, 2 electron bond shown in paper. This bond is what is called Sanoy, boron. This is called banana bonding. You see here down. 2 center, 3 electron. Na? This is called, here you see,
So this one.
banana bond. See, same. Bonding in diborane, each boron atom uses sp3 hybrid orbital bonding out of the 4 sp3 hybrid. On each boron atom, one without an electron shown in broken line. The terminal BH bond are normal 2 center 2 electron bond, but the two bridge bond are 3 center 2 electron bond. The 3 center 2 electron bridge bond are referred as banana bond. So this is what the 3 center 2 electron bond are called banana bond. Okay. These points you study by yourself little bit if you are having time. Uses also, that is what aluminum is used in the what, that is manufacturing of what, that is the aircraft, body of the aircraft. Okay, application of borax are there. No, the main boric acid. Application of borax, what we are using, the boric acid. Resistance glasses you are making, no, glass wood you are making, no, fibers you are making. This all things you are making this one, right? So this is what the once you go with this one and you read with the this one. So what I am doing, Sanway, now I am going outside. Okay. So group 14 element, whatever they are there, that is carbon family, that most of the things you will study. Similar terms are there. Okay. P block. See the group 14 condition. What are there? This all the general properties are similar like that. Ionization, this all the things you can go. You can once you see this one, the chart of this one for the group 14 element. This chart you can see. Okay. Next one you can see. Compounds are not that much or the significant one. That is silicon compound are there. No, this can come silky acid. Allotrop of carbon that you study in the 10th standard, there is no problem. Some carbon compounds are there, that carbon monoxide, carbon dioxide, these are there. Very less are there. You can give the half an hour that you will be able to understand, because carbon and compound we study na last year. So this can be helpful. So now it's very late for me and I am also getting very tired of this one. It's taking long time. So this one you finished by yourself. In case of problem, you text me. I will try. And your problem till now, I did not go through the problem, didn't get the time. Today, if I will get the time, I will reply back. Okay, Sanoy?
Okay.
Okay, all the best.
Thank you.